Now let's understand what vision agents are and build a hands-on project. Okay, so vision agents are the agents that can see. This means the agent can accept image as input or use a visual perception tool as part of its toolbox. Okay, for example, a vision enabled agent could analyze a chart image you give or control a web browser by interpreting screenshots of a page, just like a human scanning a web page, right? So small agents support vision models, and this will allow agents to perform tasks that involve images or a visual environment. Okay, so with this understanding on vision agents, let's build a vision agent by using small agents. So I'm using Google Colab, but you can use any code editor. Okay, first let's install all the dependencies. That is, let's install the small agents open telemetry packages using pip install. You can click on this run button to run this cell. So with this we installed the required packages, and then the next step is we are trying to log into the Hugging Face Hub to have access to the inference API. So once you run this cell, you are successfully logged into Hugging Face, and you should be able to use the models from Hugging Face. Next, let's pass some images to the agent at the beginning of the agent's execution and store them as images. So the agent then processes these images throughout its execution. Let's understand what we are doing here. We are downloading images from Wikipedia and loading them into Python as PIL image objects so we can work with them. Okay, so we defined a list of image URLs in this variable. Both are Joker images from Wikipedia. After that, we created an empty list called images to store processed images. Then inside this loop, for each URL, we are setting a user agent header, so the request looks like it's coming from a browser because some sites block non-browser requests. Okay, in the next line we are downloading the image data from the web, and the next line, response.content, gives us the raw bytes of the image, and bytes.io turns those bytes into a file-like object in memory, and image.open loads that into a PIL image. Okay, and convert RGB ensures the image is in RGB format. This is important for consistency, especially for image processing. Okay, and finally the image object is appended to the images list. So images contains two PIL image objects that you can display, manipulate, or feed into models. So in short, it fetches images from URLs and then converts them into usable image objects, and finally store them in a list. Okay, let me open these images from Wikipedia. For example, assume this scenario. Let's say you have a scenario where you want to verify the identities of the superheroes attending the party. Okay, and you already have a golden data set of images from previous parties with the names of the guests. So whenever there is a new visitor image, then the agent's task is to compare this image with the existing golden dataset and make a decision about letting the guests in or not. So in this case, a guest is trying to enter and you suspect that this visitor might be the Joker impersonating Wonder Woman. Okay, so you need to verify their identity to prevent anyone unwanted from entering into the party. Assume this is the background of our project. Okay, so the agent's task is to compare the images that we provided to the existing golden data sets and determine if the guest can enter the party or not. Okay, that's what we are trying to achieve here. So with this background, let's build a vision agent that can perform our task. First, the images are loaded. In this case, we used images from Wikipedia to keep the example minimal, but imagine the possible use cases. Okay, so now we have the images, and the agent will tell us whether the guest is actually a superhero, that is Wonder Woman, or a villain, that is the Joker. Next, set the OpenAI API key here, or you can also store it in the secret keys and read it from there. Okay, after that we are setting the Langfuse to inspect the agent's behavior here. Set your Langfuse public and secret key. I have already shown you how to get the public and secret keys from Langfuse in the previous lecture, right? And once you run this cell, we set the Langfuse environment variables successfully. Next, we are setting up tracing or observability so our app can send telemetry data or spans to a backend for monitoring. Tracer provider creates the core tracing system. OTLP span exporter defines where to send trace data, that is via OTLP or over HTTP, usually to a service like OpenTelemetry. Okay, then the simple span processor sends each trace span immediately as it's created. This is good for debugging, not ideal for high performance. And add span processor connects the exporter to the tracer. Then small agents instrument or dot instrument automatically hooks into the smolagents library. So its operations like model calls, agent steps, etc. are all traced without you manually adding logging. Okay. With this, our small agents workflows will now generate trace data and send it to an observability backend for debugging or monitoring. Okay. And here we are instantiating the code agent from small agents. And for the model, we are using the OpenAI model, which is GPT-4o. Also, you can see our code agent doesn't have any tools. The agent only has access to the OpenAI model, which is a vision model. And the task of the agent is to look at the images and tell us what exactly is present in a given image. So with this, we saw both text-based agents in the previous lectures as well as vision-based agents in this lecture, right? And make sure you run this. I already ran this code. You can see the same thought action observation loop here, right? The thought is, I will describe the costume and make and identify the character. Action is made as code call since our agent is code agent, right? Then we are moving to step 1 to step 2, etc. And the agent finally gave us the answer. And the printed response is here. In this case, the output reveals that the person is impersonating someone else. So we can prevent the joker from entering the party, okay? Because we provided joker images to our agent, but you can replace those images with your project files and see if the vision agent is performing the task you assigned, right? With this, you get the idea, right? So you can explore more by doing different project scenarios, okay? And you can go to Langfuse and see the tracing of our code agent as well. I already ran a couple times. Let me open the trace. Just click on it. Here you can clearly see the agent's traces and understand how it performed the action or task, right? So with this, we understood how to build the vision agent using small agents, and also we inspected the agent's behavior and how it executed the task and gave us the result. All right.